students, in the previous videos we discussed some questions based on symmetric and skew symmetric we discussed, and now my dear students, today's class I am going to discuss the question. You can take it as the question or you can take it as the theorem. So very important, and my dear students, for 3 marks they will ask such type of question, and here it is. This question was asked in Karnataka board examinations March 2017. They asked for 3 marks. So my dear students, to prove such type of questions, please observe. First we'll read the question. So what is the question? If A and B are symmetric matrices of the same order, then show that AB is a symmetric. My dear students, we should show that AB is symmetric. Here it is. AB is symmetric if and only if. They told that if and only if condition. Here it is. If and only if A and B commute. So A and B commute means that is nothing but AB is equals to BA. Clear? So my dear students, here there are two statements are there in the given question or theorem. You can take it as a theorem or question. So there are two statements you can observe. What are those? We should show that AB is symmetric if and only if AB is equals to BA. A and B commute means what? AB is equals to BA. So the meaning of this is AB is symmetric only if and only if AB is equals to BA. That we should show. So my dear students, already we discussed in the first PUC if and only if condition. So if and only if condition, that is in the topic mathematical reasoning we discussed if and only if condition. So whenever we have the statements like this, here my dear students, here if we have the statements like this, P implies Q. So P is the one statement and Q is the one statement. So if you want to prove, here it is such type of question, if and only if, here it is, this is in the notation I am writing, P double implication Q. So P if and only if Q, if we have the statement like this, to prove such type of question, first we should take, my dear students, first we should take the statement P. Let us take the P. By considering P, we should end up with Q. Clear? And similarly, next, my dear students, we should take the conversely we should take the reverse process. So first we should take the statement P. We should assume the statement P and we should end up with Q. It means we should prove the result Q. And next, in the conversely, in the reverse, again we should take the reverse process. First only we should take this statement and then we should prove this statement. The given whatever we took the P statement, Q implies, that is nothing but here in the first part we are going to prove P. This is P is the one statement and Q is the one statement. We will consider the statement P and we will end up with the result Q. And next part we should show that conversely we should take the last result, that is Q we should take, and then we should prove the P result P. Like this we will prove. That we discussed in the previous videos. So my dear students, not the previous videos, the first year I discussed. So my dear students, so here it is. This is just the theory behind this. What I am going to, how I will prove that I told here. This is theory behind this I am using here. Clear? So my dear students, as I told here, AB is symmetric if and only if AB is equals to BA. It means that here, whatever I marked here, this AB is symmetric. First I will consider this one. That is, I will consider first, my dear students, I will consider this result. I will consider AB is a symmetric and I will prove AB is equals to BA. And next, conversely, what I will do, I will consider this part. Reverse, I will prove. I will take AB is equals to BA and then I will prove that AB is symmetric. Clear? So for that, first I will consider, my dear students, let AB is symmetric. So my dear student, you can observe, if AB is symmetric, so before that we should know what is meant by symmetric and skew symmetric. Already discussed. We should know what is the symmetric matrix means. So my dear students, A is said to be symmetric. A matrix A is said to be symmetric if A transpose equals to A. Clear? that I discussed in the previous videos. So any matrix A is said to be a symmetric if A transpose equals to A. So my dear students, here what they told? They told that let us, I am taking here this AB is symmetric. Already AB is symmetric. So AB is symmetric means this implies that this is already symmetric. So symmetric, being a symmetric, it satisfies this condition. AB whole transpose must be equals to AB because AB is symmetric. I am taking here this. Let us take. We should only consider. Let us. I am taking AB is symmetric. So AB is symmetric. So being it is a symmetric, it satisfies this condition. Therefore, this implies that AB whole transpose is equals to AB, and call this as result 1, my dear students. But what we know, but by the properties in the case of the after the definition of the transpose of a matrix, in the previous videos I discussed the property. What is that? AB whole transpose can be written as B transpose into A transpose. Call this as result 2. But we know that AB whole transpose can be written as B transpose into A transpose. This is by the property of a transpose of a matrix. Clear? So you can write here this property. By the property of transpose of a matrix, I wrote this AB whole complete, the whole dash is equals to B dash into A dash. Now my dear students, here AB whole dash is equals to AB, and here AB whole dash is equals to B dash into A dash. So by merging this, okay, we will merge these two results. That is from 1 and 2, I write AB whole transpose equals to AB and AB dash whole transpose equals to B transpose into A transpose. So therefore LHS are same. So therefore RHS also equal. So therefore AB is equals to B transpose into A transpose. And next, my dear students, can I write B transpose as B and A transpose I write it as A? Because A and B are symmetric. Because already they given to you A and B are symmetric matrices. So therefore being a and B are symmetric. So therefore I can write B transpose equals to B and A transpose equals to A. So this implies that AB is equals to BA. Clear? So therefore my dear students, AB is equals to BA. So what I did here is, so first I consider this statement. AB is symmetric. I assumed this result. I took the AB is symmetric, and next at the end I prove this result. That is A and B are commute. Clear? AB is equals to B. That I discussed. So next, my students, as I told here is, first this is the one statement. This is the one statement. Whenever we have if and only if condition, first we should consider the first part, and then we should end up with the second result. Second part, whatever we have, this statement Q. That I proved here this. Now my dear students, we should show the conversely. We should show that. So how to show the conversely? We should take the reverse. First only we should assume this, and we should end up with this result. So like this we should prove whenever in the statement if you have if and only if condition. So if you have if and only if condition in the given question or in the given theorem, always we should prove like this. First you should take the first statement, and then you should end up with the second statement result. And next, conversely, we should take reverse process. Second statement first we should take, and we should show the first statement. Clear? So now my dear students, conversely, next I will take conversely. Well, first only I am proving now reverse. So first only I will take if AB is equals to BA. If AB is equals to BA, then we should show that our AB is symmetric. Clear, my students? First I have taken this and I should show this result. So therefore I wrote here this: if AB is equals to BA, we shall show that AB is symmetric. To prove this, now consider, my dear students, AB whole transpose is equals to, AB is equals to BA. Clear? Now take the transpose on both sides. So if you take the transpose on both sides, AB whole transpose is equals to B transpose into A transpose. Clear? And now my dear student, AB whole transpose is equals to here B transpose into A transpose. B transpose into A transpose. Can I write it as B into A? Clear? Because as I told here, it is A and B are symmetric. So B transpose can be written as B, A transpose can be written as A, because since A and B are symmetric. So what is that? If A and B are symmetric means what? That is A dash equals to A and B dash equals to B. Clear? By this result I am writing B transpose equals to B, A transpose equals to A. And next, my dear students, I can prove this AB whole transpose as it is I am writing, and BA I can write it as AB. This BA I can write it as AB because A and B are symmetric matrices. My dear student, you can observe here it is, if you multiply, here it is, if you take if A and B are the symmetric matrices, then AB and BA values are same. So if you multiply AB and BA if you multiply A with B, then the result will get the result same as B into A if you multiply B with A. Clear? So this is my dear students, this is possible if A and B are symmetric. So therefore I can write AB, already I wrote here it is, therefore AB whole transpose equals to AB. So AB whole transpose equals to AB means what? Then we can write here it is, this implies that AB is symmetric. Clear? So my dear students, what I did, first I assumed AB is symmetric and I end up with the result AB is equals to BA, and next I proved the reverse. First only I considered AB is equals to BA, and then I shown here it is AB is symmetric. Like this you can prove. Very important. For 3 marks they will ask. So I hope you understood. Still if you have any doubts you can comment me, I will reply for that. So once I explain in Kannada. So ನೋಡಿ, ಯಾವಾಗಲಾದರೂ ನಮಗೆ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಏನು ಕೊಟ್ಟಾರ, A ಮತ್ತು B ಅನ್ನೋದು ಏನು ಹೇಳ್ಯಾರ, A ಮತ್ತು B ಅನ್ನೋದು ಎರಡು ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಸಸ್ ಅದಾವ ಅಂತ ಹೇಳ್ಯಾರ ಆಫ್ ದ ಸೇಮ್ ಆರ್ಡರ್. Then show that AB is symmetric if and only if A and B commute that AB is equals to B. ಅಂದ್ರ ಮೀನಿಂಗ್ ಏನು ಹೇಳ್ಯಾರ ಅಂತ ಹೇಳಿದ್ರ, AB ಸಿಮೆಟ್ರಿಕ್ ಇರ್ತೈತಿ if and only if, ಯಾವಾಗ ಅಂತ ಹೇಳಿದ್ರ AB is equals to BA, AB ಮತ್ತು AB, if AB is equals to BA ಇದ್ರೆ ಮಾತ್ರ ನಾವೇನ್ ಹೇಳ್ಬೋದು, AB is equals to BA ಇದ್ದಾಗ ನಾವು AB ಅನ್ನೋದನ್ನ ಸಿಮೆಟ್ರಿಕ್ ಅಂತ ಹೇಳ್ಬೋದು. ಇದನ್ನ ಪ್ರೂವ್ ಮಾಡ್ರಿ ಅಂತ ಹೇಳಿದ್ರು. ಸೊ ನಾವೇನ್ ಮಾಡ್ಬೇಕಂತ ಹೇಳಿದ್ರೆ, ಯಾವಾಗಲೂ ಇಫ್ ಅಂಡ್ ಓನ್ಲಿ ಇಫ್ ಕಂಡೀಷನ್ ಇತ್ತಂದ್ರ ನಾವೇನ್ ಮಾಡ್ಬೇಕಂತ ಹೇಳಿದ್ರೆ, ಮೊದಲೇನ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇರ್ತೈತಿ ಅದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡು ಅದನ್ನ ತಗೊಂಡು, ಸೊ ಲೆಟ್ AB is ಲೆಟ್ AB is symmetric, ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನ ತಗೊಂಡ ನಾ ಏನ್ ಪ್ರೂವ್ ಮಾಡಬೇಕು, ಇಫ್ ಅಂಡ್ ಓನ್ಲಿ ಇಫ್ ಅಂತ ಏನ್ ಕೊಟ್ಟಿರ್ತಾರಲ್ಲ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಸೊ ಅದನ್ನ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ನೆಕ್ಸ್ಟ್ ನಾವು ಕನ್ವರ್ಸ್ಲಿ ಮತ್ತೆ ಏನ್ ಮಾಡಬೇಕು, ಉಲ್ಟಾ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಉಲ್ಟಾ ಅಂದ್ರೆ ಸೆಕೆಂಡ್ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನು ತಗೊಂಡು ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಸೊ ಈ ರೀತಿ ಯಾಕೆ ಮಾಡ್ಬೇಕಂತ ಹೇಳಿದ್ರೆ, ನಮ್ಮ ಕಂಡೀಷನ್ ಏನು ಇಂಪ್ಲೈಸ್ ಡಬಲ್ ಇಂಪ್ಲಿಕೇಶನ್ ಅಥವಾ ಇಫ್ ಅಂಡ್ ಓನ್ಲಿ ಇಫ್ ಕಂಡೀಷನ್ ಇದ್ದಾಗ ಈ ರೀತಿ ಮಾಡ್ಬೇಕಂತ ಹೇಳಿ ನಾವು ಫಸ್ಟ್ PC ಅಲ್ಲಿ ಕಲ್ತಿದ್ವಿ. ಕ್ಲಿಯರ್? ಸೊ ಅದೇ ರೀತಿ ಇಫ್ ಅಂಡ್ ಓನ್ಲಿ ಇಫ್ ಐತಿ, ಅದಕ್ಕೋಸ್ಕರ ಇದೇ ಪ್ಯಾಟರ್ನ್ ಅಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡಕತ್ತಿದೆ. ಸೊ ಇದನ್ನ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನು ತಗೋತಾನೆ, AB is symmetric. ಸೊ AB ಸಿಮೆಟ್ರಿಕ್ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡೇನೆ. ಲೆಟ್ ನಾನು ಅನ್ಕೊಂಡೆ AB ಸಿಮೆಟ್ರಿಕ್ ಅಂತ ತಗೊಂಡೆ ಸಾಲ್ವ್ ಮಾಡ್ಲಿಕ್ಕೆ. ಸೊ ಲೆಟ್ AB ಸಿಮೆಟ್ರಿಕ್ ಐತೆ ಅಂತ ಹೇಳಿದ್ರೆ ನಮ್ಗೆ ಏನು ಗೊತ್ತೈತಿ, ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ A ನ ಸಿಮೆಟ್ರಿಕ್ ಅಂತ ಹೇಳಬೇಕಂದ್ರೆ ಏನಾಗಿರ್ಬೇಕು, A ಟ್ರಾನ್ಸ್ಪೋಸ್ ಈಕ್ವಲ್ಸ್ ಟು A ಇರಬೇಕು. ಅದೇ ರೀತಿ AB ಅನ್ನೋದು ಸಿಮೆಟ್ರಿಕ್ ಐತೆ ಅಂತ ಹೇಳಿದ್ರೆ AB ಹೋಲ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಏನಾಗಿರ್ತೈತಿ, AB ನೇ ಇರಬೇಕು. ಕ್ಲಿಯರ್? ಅದಕ್ಕೆ ಇದನ್ನ AB ಸಿಮೆಟ್ರಿಕ್ ಇರೋದ್ರಿಂದ ಈ ಕಂಡೀಷನ್ ಅನ್ನ ಬರುತ್ತೆ. ಇದನ್ನ 1 ಅಂತ ಕರೀತಾರೆ ಕಂಡೀಷನ್. ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ನಮ್ಮ ಪ್ರಾಪರ್ಟೀಸ್ ಅಲ್ಲಿ ಏನು ಗೊತ್ತಿತ್ತು, ಪ್ರಾಪರ್ಟಿಯಲ್ಲಿ AB ಹೋಲ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅನ್ನು ಹೆಂಗ್ ಬರೀಬಹುದು ಅಂತ ಹೇಳಿದ್ರೆ B ಟ್ರಾನ್ಸ್ಪೋಸ್ ಇಂಟು A ಟ್ರಾನ್ಸ್ಪೋಸ್. ಇದನ್ನ ಪ್ರಾಪರ್ಟಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಟ್ರಾನ್ಸ್ಪೋಸ್ ಆಫ್ ಅ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಡೆಫಿನಿಷನ್ ಆದ ನಂತರ ಪ್ರಾಪರ್ಟೀಸ್ ಬರೆಯೋದನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡಿ. ನೆಕ್ಸ್ಟ್ ಇವೆರಡನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ AB ಹೋಲ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅಂದ್ರೆ AB ಅಂತ ಬರೀಬಹುದು, AB ಹೋಲ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅನ್ನು B ಟ್ರಾನ್ಸ್ಪೋಸ್ ಇಂಟು A ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅಂತ ಬರೀಬಹುದು. ಇವೆರಡು ಕಂಡೀಷನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ನಾನು ಬರೆದೆ. ಇಲ್ಲಿ LHS ಇಲ್ಲಿ LHS ಮತ್ತೆ ಇಲ್ಲಿ LHS ಸೇಮ್ ಇರೋದ್ರಿಂದ AB ಹೋಲ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅನ್ನ AB ಅಂತ ಬರೀಬಹುದು, AB ಹೋಲ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅನ್ನ B ಟ್ರಾನ್ಸ್ಪೋಸ್ ಇಂಟು A ಟ್ರಾನ್ಸ್ಪೋಸ್ ಬರೀಬಹುದು. ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಬರೆದೆ AB is equals to B ಟ್ರಾನ್ಸ್ಪೋಸ್ ಇಂಟು A ಟ್ರಾನ್ಸ್ಪೋಸ್. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ B ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅಂದ್ರೆ ನಾನು B ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅನ್ನ ಏನು ಬರೆಯಕತ್ತೀನಿ, ಬಿ ಅಂತ ಬರೀತೇನೆ, ಎ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅನ್ನ ಎ ಅಂತ ಬರೀತೇನೆ. ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಮತ್ತೆ ನಮ್ಗೆ ಏನ್ ಗೊತ್ತೈತಿ ಎ ಅಂಡ್ ಬಿ ಆರ್ ಏನಂತ ಹೇಳಿ ಸಿಮೆಟ್ರಿಕ್ ಅಂತ ಹೇಳಿ. ಸೊ ನಮಗೆ ಏನ್ ಗೊತ್ತೈತಿ ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಎ ಅನ್ನೋದು ಎ ಇರಲಿ ಬಿ ಇರಲಿ ಏನಾದ್ರೂ ಇರಲಿ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು ನಾವು ಸಿಮೆಟ್ರಿಕ್ ಅಂತ ಹೇಳ್ಬೇಕಂದ್ರೆ ಈ ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗ್ತಾ ಇರಬೇಕು, ಎ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎ. ಸೊ ಎ ಮತ್ತು ಬಿ ಸ್ಟಾರ್ಟಿಂಗ್ ಅವ್ರು ಹೇಳ್ಯಾರ ಎ ಅಂಡ್ ಬಿ ಆರ್ ದ ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳಿರೋದ್ರಿಂದ ನಾ ಏನ್ ಬರೀಬಹುದು ಬಿ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಬಿ, ಎ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎ. ಸೊ ದೇರ್ಫೋರ್ ಎ ಬಿ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಬಿ ಎ. ಸೊ ನಾ ಏನ್ ಮಾಡಿದೆ ಎ ಬಿ ಇಸ್ ಸಿಮೆಟ್ರಿಕ್ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನು ತಗೊಂಡೆ, ಇಫ್ ಅಂಡ್ ಓನ್ಲಿ ಇಫ್ ಇರೋದ್ರಿಂದ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡು ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನು ಪ್ರೂವ್ ಮಾಡಿದೆ. ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡಬೇಕು ಕನ್ವರ್ಸ್ಲಿ ಮತ್ತೆ ರಿವರ್ಸ್ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಫಸ್ಟ್ ಇದನ್ನ ತಗೋಬೇಕು. ಸೊ ನಾ ಏನ್ ಮಾಡ್ತೇನೆ if AB is equals to BA ನಾ ಇದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿ ಇದನ್ನ ಈ ರಿಸಲ್ಟ್ ಅನ್ನು ತೋರಿಸಬೇಕು AB is symmetric ಅಂತ ಹೇಳಿ. ಅದಕ್ಕೋಸ್ಕರ AB is equals to BA ಅಂತ ಹೇಳಿ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಇದನ್ನ ತಗೊಂಡೆ, ಯಾವುದು ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಕೊಟ್ಟರೆ ಇದನ್ನ ತಗೊಂಡಿದ್ದೇನೆ AB is equals to BA, ಇದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿ AB is symmetric ಅನ್ನೋದು ಶೋ ಮಾಡಬೇಕು. ಸೊ ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತೇನೆ ಎರಡು ಸೆಟ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ತಗೋತೇನೆ, ಎರಡು ಸೆಟ್ ಹೋಲ್ ಡ್ಯಾಶ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ತಗೊಂಡಾಗ AB ಹೋಲ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಈಕ್ವಲ್ಸ್ ಟು B ಟ್ರಾನ್ಸ್ಪೋಸ್ ಇಂಟು A ಟ್ರಾನ್ಸ್ಪೋಸ್ ಜಸ್ಟ್ ಈ ಕಂಡೀಷನ್ ಗೆ ಟ್ರಾನ್ಸ್ಪೋಸ್ ತಗೊಂಡೆ. ಸೊ AB ಹೋಲ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಮತ್ತೆ B ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅನ್ನು ಹೆಂಗ್ ಬರೀಬಹುದು B ಅಂತ ಬರೀಬಹುದು, ಯಾಕ ಆಲ್ರೆಡಿ ಇದೆ A ಮತ್ತು B ಏನದಾವ ಸಿಮೆಟ್ರಿಕ್. ಆಮೇಲೆ A ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅನ್ನು A ಅಂತ ಬರೆದೆ. ನೆಕ್ಸ್ಟ್ ದಿಸ್ ಇಂಪ್ಲೈಸ್ AB ಹೋಲ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಆಮೇಲೆ BA ನ ಹೆಂಗ್ ಬರೀಬಹುದು ಅಂತ ಹೇಳಿದ್ರೆ ನಾವು AB ಅಂತ ಕೂಡ ಬರೀಬಹುದು. ಯಾಕಂತ ಹೇಳಿದ್ರೆ A ಮತ್ತು B ಎರಡು ಸಿಮೆಟ್ರಿಕ್ ಅದಾವ, ಎರಡು ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನ ನೀವು ಆರ್ಡರ್ ಚೇಂಜ್ ಮಾಡಿ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರು ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಇರ್ತೈತಿ, BA ನ ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಇರ್ತೈತಿ, AB ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಇರೋದ್ರಿಂದ BA ನ AB ಅಂತ ಬರೀಬಹುದು. ನೆಕ್ಸ್ಟ್ AB ಹೋಲ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಈಕ್ವಲ್ಸ್ ಟು AB ಇರೋದ್ರಿಂದ AB ನ ನಾವು ಏನಂತ ಹೇಳ್ಬೋದು ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳಬಹುದು. ಸೊ ದೇರ್ಫೋರ್ ಇದು ನಿಮ್ಮದು ರಿಸಲ್ಟ್. ಈ ರೀತಿ ನಾವು ಪ್ರೂವ್ ಮಾಡ್ತೀವಿ. ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ 3 ಮಾರ್ಕಿಗೆ ಈ ರೀತಿ ಕ್ವೆಶ್ಚನ್ಸ್ ಅನ್ನ ಕೇಳ್ತಾರೆ. ಸೊ ಇನ್ನೂ ಏನಾದರೂ ನಿಮ್ಗೆ ಡೌಟ್ಸ್ ಇದ್ರೆ ನೀವು ಕಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಕಮೆಂಟ್ ಮಾಡಿ, ನಾನು ನಿಮಗೆ ಮತ್ತೆ ರಿಪ್ಲೈ ಮಾಡ್ತೇನೆ, ಏನು ಹೇಳ್ತೇನೆ ನಿಮಗೆ ಏನಾದ್ರು ಡಿಸ್ಕಷನ್ ಬೇಕಿದ್ರೆ. ಕ್ಲಿಯರ್? ಎಸ್. And next my students we will move to the next question. Next we will move to the next question. Please pause the video to note it down. And the next question is here. Next question everyone. The next question is for the matrix A, for the matrix A is equals to one, two, three, four. Verify that the first condition is A plus A transpose is a symmetric matrix. Is a symmetric matrix, and the second condition is A minus A transpose is a skew symmetric matrix. My dear students, already based on this theory part I discussed. So theory part ಹೇಳಿದ್ದೇನೆ ನಿಮಗೆ. ಸೊ ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ E ನ ನಾವು ಏನಂತ ಹೇಳ್ಬೋದು, ಸೊ ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಗೆ A ಗೆ A plus A dash ಅನ್ನೋದು ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಗಿರ್ತೈತಿ, A minus A dash ಅನ್ನೋದು ಸ್ಕ್ಯೂ ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಗಿರ್ತೈತಿ. ಸೊ ಕ್ಲಿಯರ್? ಸೊ ವೆರಿಫೈ that. So my dear students, for any matrix A plus A dash is a skew symmetric matrix and A minus A dash is a skew symmetric matrix. So ಇದರದ್ದು ಈ ರೀತಿ ಇರೋ ನಾನು ಥಿಯರಿ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಒಂದು ಪ್ರೂವ್ ಮಾಡಿದೆ. ಏನು? for any matrix A plus A dash is a symmetric matrix, A minus A dash is a skew symmetric matrix. Now they given to you one example, that is one particular matrix they given to you, then that we should show that A plus A dash is a symmetric and A minus A dash is a skew symmetric matrix. So to prove this, first we should know the A plus A transpose values. So my dear student, if I wanted to show A plus A dash is a symmetric means what should I show here? So I should show that to prove this result here A plus A dash is a symmetric. What they ask? A plus A dash is symmetric. So I told already, a matrix, if I wanted to show any matrix A is a symmetric, means we should show that A transpose equals to A. Clear? For any matrix A, if I want to show this matrix is a symmetric, means we should show that A transpose must be equals to A. See, like this, we should show that A plus A dash is a symmetric matrix. So if I wanted to show A plus A dash is symmetric, means A plus this if I have a matrix A, then this matrix whole transpose must be equals to A. Similarly, if I want to show A plus A dash is a symmetric, means I should show that this transpose must be equals to itself A plus A transpose only. So my dear students, A plus A dash is a symmetric, means we should show that A plus A transpose whole transpose value must be equals to A plus A transpose. I hope you understood. So for this, to show this result, I should know the value of, here I should know A plus A transpose whole transpose I require. So for that reason, first I will find out the A transpose, because already they given to you matrix A, they given to you. You should write the A transpose, and that already we discussed how to write the A transpose. That already I discussed. I think in the transpose of a matrix, in that concept I explained how to write the transpose of a matrix. So transpose of a matrix can be written by interchanging the rows into columns. So my dear students, here the matrix A is, here the matrix A is, what is that? A is equals to 1 2 3 4. Next, my dear students, I will take the A transpose. So how to write the A transpose? Interchange the rows into column. 1 2 3 4. This is your A transpose. But I require A plus A transpose whole transpose. So therefore A plus, here A plus, here A plus A transpose. First I will find out the A transpose. Clear? So therefore, what is A, my dear students? A is 1. Here it is 1 2 3 4. This is A. A plus A transpose. Here A transpose is 1 3 2 4. So therefore, this is equals to, add these two matrices. So 1 plus 1 is 2, 2 plus 3 is 5, 3 plus 2 is 5, 4 plus 4 is 8. Clear? My distance, now I should consider the E. This is A plus A transpose is this much, 2 5 5 8. I required A plus A transpose whole transpose. If this value is also I got the same as A plus A transpose, then we can say that A plus A dash is a symmetric matrix. For that, I will find A plus A transpose whole transpose. So what is the whole? A plus A transpose is this much. Now we should consider the whole transpose, that is the transpose of this matrix. So that is 2 5 5 8. Clear? So here it is A plus A transpose is 2 5 5 8. And even if I consider A plus A transpose whole transpose, again I am getting 2 5 5 8. These two matrices are equal. Therefore, here it is. Therefore, A plus A transpose whole transpose is same as A plus A transpose. Clear? So therefore, we can write here. I write there due to lack of space. Therefore, A plus A dash is a symmetric matrix. Is a symmetric matrix. Clear, my dear students? Next, we will prove the second part. Whatever I shown here it is. This is the first part. Or else here I can write. This is the first part I shown here it is. A plus A dash is a symmetric. And now I will show that A minus, here it is, A minus A dash is a skew symmetric. So my dear student, this is for the symmetric. Clear? If I wanted to prove for the skew symmetric, so skew symmetric means we should show that for any matrix A, if I wanted to show A is a skew symmetric, means I should consider A transpose must be equals to minus A. Clear? Like that, now I should show that A minus A transpose. So A minus A transpose as a skew symmetric. So therefore I will consider the transpose of this. That is A minus A dash whole transpose must be, this whole transpose must be equals to here minus of A minus A transpose. Clear? Minus of this value A minus A transpose. So either you can do like this, or if you take the minus inside, so this will become minus A minus minus plus A transpose. Clear? So now my job is to show that A minus A transpose whole transpose must be equals to minus of A minus A transpose, or else minus A plus, here it is, minus A plus A transpose. So for this I required A minus A transpose. So already I know A and A, my A transpose. I will find out A minus A transpose first. A minus A transpose equals to, what is A, my dear students? 1, 2, 3, 4. This is your matrix A minus A transpose. What is A transpose? 1, 3, 2, 4. And this is equals to, here it is. Subtract these two matrices. 1 minus 1 is 0. 2 minus 3 is minus 1. 3 minus 2 is 1. 4 minus 4 is 0. Clear? This is your A minus A minus A transpose value is this much. Next, my students, here I should show that A minus A transpose whole transpose value also are required. So therefore I consider A minus A transpose whole transpose. I will take the transpose of this. If I take the transpose of this, again I should interchange rows into column. That is 0 minus 1, 1, 0. So this is your, my difference, A minus of A transpose whole transpose. Can I write? But my aim is to prove that A minus A dash whole dash, this must be equals to negative of A minus A dash. Negative of A minus A dash. So for that reason, I will take here this. From this, I will take the minus outside. So if I take the minus outside, so here it is 0, here it is minus 1, 1, 0. I am taking minus outside from this. That already discussed. Whenever you take the sign outside, so after multiplying this, the sign with this matrix, after multiplying each element of the matrix, you should get this matrix only. If you get this, then whatever you took the common, that or else outside whatever you took the sign, that's correct. So I'll check once. Minus 0 into 0, minus 0 into 0 is 0. Minus minus into minus 1 is plus 1. Minus into 1 is minus 1. Minus into 0 is 0. So therefore, my dear student, so this is whatever from this I took the minus outside. So whatever I took the minus outside, so this is correct. Just I verified. Clear? Now you can observe. So therefore, A minus A transpose whole transpose is equals to, keep the minus sign as it is, and we know that 0 minus 1 1 0, 0 minus 1 1 0. This means what? This means A minus A transpose. Clear? So that is what I proved here. This A minus A transpose whole transpose is equals to negative of A minus A transpose. Negative of A minus A transpose. So if this condition satisfies, therefore now you can say that A minus A transpose is skew symmetric matrix. Skew symmetric matrix. Clear? Because already we know. So any matrix A, if I for any matrix A, if I wanted to show that this matrix is a skew symmetric, I say this A matrix is a skew symmetric if A transpose is equals to minus A. Like that, I should show that A minus A transpose is a skew symmetric, because A minus A transpose whole transpose is equals to negative of this A minus A dash. So therefore, A minus A transpose is a skew symmetric matrix. So like this, they'll ask the questions, my dear students. Please try to solve such type of questions. This is also very, very important. So this question is also they'll ask for the 2 mark or 3 mark. Sometimes they'll ask. So here no need to explain in Kannada, so I won't explain. So my dear students, still if you have any doubts, you can comment me. I will reply for them. Thank you. Next we'll continue with the elementary operations. Clear? Thank you.